Hello, my name is Zach T, and today we're going to learn about trigonometric function. So first thing, what is trigonometric function? Well, trigonometric. Let us break down the word trigonometric function. Trigonometric is the study of triangles, their lengths and angle, etc. The word trigonometric came from the Greek word of trigonometron. Sounds kinda same, right? Trigonon meaning triangle and metron meaning measure. The two words combine to equal the word triangle measure, like the measurement of triangles. Trigonometric function is the method that explains the relation between sine, hypotenuse, and angles. Signs like the adjacent or opposite that we'll learn later, like right now. We have three distinct formula or function for trigonometry is sin, cosine, and tangent. The sin formula is the opposite divided by hypotenuse, and cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. But we're going to learn about cosine for today. Sin and tangent we'll learn probably another day. So first thing, cosine. A cosine function is cosine and this thing called an angle is equal to adjacent divided by hypotenuse. I have a picture next to it to explain. Like this thing, this angle equal to this divided by this. Let me use an example for easier to understand the formula. We have the angle here, 55 degree, and the adjacent is 57 degree, and we have an unknown variable is the hypotenuse. We want to find it, so just use the cosine to find out the hypotenuse. Just plug in the number, like the angle at first is 55 degree here, and the adjacent length is 57 centimeters, and the hypotenuse is we don't know, so we're going to find it. Nice. If we want to find the hypotenuse, we have to multiply 57 multiplied by cosine of 55. Well, I'm not a genius, so I use calculator. I don't know if anyone can calculate it in mind. I don't know. So if we plug in the number into our calculator, kinda easy though, we get the number 69.58 centimeters. Wow, imagine 69.58 centimeters. Easy to understand, right? And next is the inverse cosine. The important part is inverse here. Inverse, just like the name, is like the opposite of the cosine. So we have this thing, I don't really understand, but we got the formula for it. Yay! Cosine, the inverse thing is -1. Cosine -1. Wait, yeah, cosine to the power of -1, I guess, equal to the adjacent hypotenuse. This formula is used to find the angle of the triangle if we know the two sides of it. let's use an example to understand this inverse cosine better. If we have the adjacent here and the hypotenuse here, but we don't know the angle, so we just use the inverse cosine. The inverse cosine, we just need to plug in the numbers, which we already have is 11.5 and 20.05. People, we use the calculator once more. Just plug in the number, it's easy. If you don't have a calculator, I don't know, you go ask a friend or something. If we plug in the number, we get 55 degrees, which is right. Believe me, I calculated. And next part of the lesson is cosine graph. Cosine graph is like the graph of the cosine. The cosine use circles, like so if we have, let's call this the angle. If we have 0 degree, the yellow line will be this, because there's no triangle. If we have 45 degree, we have a triangle. See, so but this part is reduced to, I don't know, some measurement, but reduced. And the 90 degree, which is became this, which is not the cosine line. The cosine line is this thing, this line, which would make the cosine line 0 centimeters something, because the line is straight up, so perpendicular, don't have any line on here. And if we go over that mark, we got 105 degree, so we get the line from this side. So if we use like the increase of 15 to graph, like 15, then 30, then 45. This part is kinda confusing, but try to understand. If we incline, the number will go up, and the line, the length of the line will go up. It will expand until it hit 90 right here. No, it's not expand, it's contract. Yeah, sorry, contract. It's contract and contact. Contract from full length is this line to none, oh, to none. Okay, until it hit over the line of 50, of 90 to get the 105, then the number will start going up again until it hit 180. This will be better to understand on this graph. Like from 0 we got this line, the longest length of the line. Then if we go to here is 45, the line will reduce because it depends on this line, on the green line. So reduce until it hit 90, which is none, no more length, 0 centimeters. And really do a very beautiful graph like this. Just a graph, you don't need to understand it much, but just need to know it. So the activity, we already done some activity up here, so let's just do something more interesting, like a word problem. Yay! Interesting, right? So we got a 20-foot ladder resting against a wall. The ladder makes a 55-degree angle with the ground. How far from the wall is the base of the ladder? So let me draw this for you guys to easier to picture it. The wall, the ladder, what? The ladder, which is 20 foot, kind of high though, I don't know. And the problem is asking for the length of this. The base is the length of the ladder to the wall on the ground. So we use cosine, which I already solved at the bottom, but can you guys figure it out? Okay, so we have this angle as 55 and the 20-foot ladder, which in this case is a triangle. See? Wow, a triangle. 55 degree here. This perpendicular to the ground, by the way, of course. And a 20-foot ladder here, which if you can look, if you can see or figure out, this is cosine. We have the angle here. This is no. What? Oh, this is the ladder, the hypotenuse. So we need to find the adjacent part. Adjacent, see? So we use the cosine formula of this. Cosine of angle equal adjacent divided by hypotenuse. So just plug in the number and we got cosine of 55 equal to adjacent over 20. 20 is the hypotenuse. So we will need to find the adjacent, which I appropriately named x. So 20 multiplied by cosine of 55 we will get the hypotenuse, or in this case x, or in the problem the length from the foot from the base of the ladder to the wall. And we got the length of 11.5 feet. Wow, I mean, just from knowing the ladder and the angle of the ladder, which is kind of hard, but somehow we knew it in real life. We can find the length from the base to the wall for some reason. Then probably we can find the length of the wall. So useful, right? So next part, real life application. Real life application, there's a lot, but I choose two interesting ones for you guys. It's not that interesting, but it's the most interesting, I guess. As you can guess from the real life problem, we got construction. Yay! We can measure few lot. I think lot here is parking lot. Areas, maybe areas, big areas. A roof inclination meaning the slope of it. Making a wall parallel or perpendicular, as you can guess, is this. Ooh. And criminology sounds interesting, so choose one. Yep. We can figure out the projectile trajectory of something. The projectile meaning object. Wow, trigonometry. Well, that's all. It's not that interesting in my opinion, but that's all.